Welcome back to Scot Tech for you. The race for the future of driving is on. Two technologies, battery electric vehicles and hydrogen fuel cell cars, promise zero emissions, instant torque, and a cleaner planet. But beneath the hood, their science, challenges, and possibilities couldn't be more different. In this documentary, we'll uncover how each system works, the breakthroughs shaping their future, and which one might dominate the roads ahead. Batteries or hydrogen? Who will power tomorrow's journey? In the coming decades, two zero-emission technologies are set to transform the way we drive. Battery electric vehicles, EVs, and hydrogen fuel cell vehicles, HFCVs. Both run on electric motors and produce no tailpipe CO2. In fact, hydrogen cars emit only water vapor as exhaust. Yet beneath these similarities lies very different science, infrastructure, and challenges. This documentary explores how each technology works, recent breakthroughs, their environmental impact, and what the future of personal transportation might look like. Electric vehicles store electricity in lithium-ion batteries. Inside these batteries, chemical reactions move lithium ions and electrons between the anode and cathode. When the driver presses the accelerator, electrons flow through the motor, generating power. This system is highly efficient, with modern EVs converting roughly 80 to 90% of stored energy into motion. Hydrogen fuel cell cars, on the other hand, carry compressed hydrogen gas. Inside the fuel cell stack, hydrogen atoms split into protons and electrons in a reaction with oxygen, producing electricity on demand. The only byproduct is water vapor. In effect, a fuel cell car is a mobile power plant, generating clean electricity as long as it has hydrogen fuel. Both technologies are advancing rapidly. On the battery side, breakthroughs in solid-state design have led to prototypes with energy densities around 375 Wh/kg, almost double today's best, and capable of charging from 15% to 90% in under 20 minutes. This points toward EVs with longer ranges, lighter packs, and ultra-fast charging. Hydrogen systems are improving as well. Toyota's third-generation fuel cell technology offers double the durability and 20% better efficiency, while Honda's next-gen CR-V fuel cell SUV reduces costs by 2/3 compared to earlier models. BMW is also returning to hydrogen with its 9.5 concept, which promises more than 300 miles of range and refueling times of only 3 to 4 minutes. These breakthroughs suggest both batteries and fuel cells are moving closer to mainstream practicality. When it comes to emissions, both EVs and HFCVs eliminate local pollution, but their overall climate impact depends on how the energy is produced. Today, most hydrogen is made from natural gas, a process that emits significant CO2. Unless hydrogen is produced from renewables, its benefits remain limited. EVs, meanwhile, can be powered by renewable electricity and already deliver substantial carbon reductions even on fossil-heavy grids. Studies show that battery electric trucks can cut lifetime CO2 emissions by 60 to 90% compared to diesel, while hydrogen trucks using fossil-based hydrogen only reduce emissions by 15 to 33%. With 100% green hydrogen, however, fuel cell vehicles could match EVs, cutting emissions by nearly 90%. Both systems still depend on resource-intensive manufacturing. EV batteries require lithium, nickel, and cobalt, while fuel cells rely heavily on platinum catalysts. Infrastructure highlights another divide. EV charging has grown dramatically, with California alone hosting nearly 180,000 chargers, including around 17,000 fast chargers, by 2024. Globally, however, hydrogen stations remain scarce, only about 1,370 worldwide, clustered mainly in Japan, South Korea, China, Europe, and parts of California. For consumers, this means EV charging is increasingly convenient, even if it sometimes requires waiting, while hydrogen drivers face limited refueling points. Yet hydrogen has the advantage of speed. Refueling takes about 5 minutes, compared to the 30 minutes or more often needed for a fast EV charge. In terms of performance, both vehicle types deliver smooth acceleration and instant torque thanks to their electric motors. High-end EVs already achieve ranges of 250 to 350 miles, with some exceeding 400. Hydrogen cars like the Toyota Mirai and Hyundai Nexo also offer 250 to 400 miles per tank. The key difference lies in efficiency. EVs convert 80 to 90% of grid power into motion, while hydrogen fuel cell vehicles convert only about 40 to 60% of hydrogen's energy into electricity. This makes EVs more energy efficient overall, though hydrogen retains an advantage in range and quick refueling. Automakers are investing in both directions. Toyota, Honda, and Hyundai continue to champion hydrogen, with Hyundai committing over $6.7 billion to scale up fuel cell production. BMW, too, is preparing to launch a hydrogen car in collaboration with Toyota. At the same time, global EV production is accelerating much faster. Tesla, GM, VW, and Stellantis are all ramping up battery electric models. EV sales reached 17 million in 2024, making up more than 20% of all new cars sold worldwide. Governments in Europe, North America, and Asia are setting strict emissions targets, effectively ensuring that EVs will dominate passenger car markets in the years ahead. Challenges remain for both. Hydrogen faces the chicken and egg dilemma. Without enough fueling stations, few buyers will commit to H2 cars, and without customers, investors hesitate to build the stations. Hydrogen production is still expensive, fuel cells require costly platinum, and storage presents safety concerns. EVs, meanwhile, grapple with long charging times, grid capacity limits, and the environmental costs of mining battery materials. But battery costs are falling steadily, while fuel cell costs remain high and in some cases are rising relative to EVs. Range anxiety for EVs is gradually easing with denser charging networks, whereas hydrogen drivers in regions like California still struggle with limited and sometimes unreliable fueling options. Looking ahead, the global market strongly favors EVs. Nearly a third of all new cars in China were electric by 2024, and EV adoption continues to surge worldwide. Hydrogen vehicles are expected to grow too, from a base of just $2.3 billion in 2024 to a projected $162 billion by 2034. A dramatic increase, though still tiny compared to the multi-trillion-dollar EV industry. The likely outcome is a mix, EVs dominating personal and urban transport, while hydrogen finds its niche in long-haul trucking, buses, and regions with abundant green hydrogen. As we've seen, both electric and hydrogen vehicles hold the keys to a cleaner, sustainable future. Batteries lead in efficiency and adoption, while hydrogen shows promise in long-haul transport and fast refueling. The road ahead won't belong to just one solution. It will be shaped by both, each playing its part in transforming how we move. Thanks for watching Scot Tech for You. Don't forget to like, share, and subscribe for more deep dives into the technologies shaping our world. And as always, drive clean, drive smart, and stay future ready.